All right, what's up, guys? Quinn with 74 Weld. I'm joined today with Eric. Eric's one of our engineers here. The goal of today's video is to do a technical dive into our steering rack. And this will be kind of the first of what we hope is going to be a long technical series. We've found that seems to be really well received, and so we're going to do a more in-depth dive into our Bronco steering rack today. So diving into this stuff, I guess we take a step back and we talk about like why even do Bronco steering as a project and where we started. And initially the conversation was actually something kind of very different. We originally looked at doing a hydraulic unit for the Bronco and looked at actually putting a steering box in the Bronco and doing a hydraulic assist. And through part of the development of the Ford 4600 race program, we knew that it was possible, but the problems that we kind of initially ran into was you're going to lose all GOAT modes, you'll lose all of your ABS compatibility. You basically have to delete ABS out of the system in order to make that work. So that was kind of a non-starter for us. So because steering is integrated into ABS, you kind of don't have much of a choice. And that's why I think, you know, we see talk about solid axle swap on a Bronco. If you're going to solid axle swap something, that's up to you. I think it's ridiculous. If you want to buy a solid axle, buy a Jeep. They are pretty nice inside too. So we basically started diving into the Bronco steering setup, and first things first, when we look at something, if we're going to try and make improvements, we want to find out what's failing and why. And so we talked about this more in depth in an earlier video about, and I'll post a link in the description about what is failing on racks. But basically, this is the passenger side of the rack. This is the driver side. We'd see failures on this side, and obviously the motor is broken off of this. And so this stuff really is happening. We kind of do a little bit deeper analysis on this, but it's a material and a design flaw. And let me be clear on this. It's a material flaw in the sense that this material can't handle shock load. It's a design flaw in the sense that when you put a big tire on this, it puts too much stress through the system. This is not what Ford intended the rack to be doing. OEs don't really care if we go off-roading or not.
Yeah. And
so don't complain and say Ford is putting out junk when you're doing something that it was never really designed to be doing. So, you know, we see failures in this housing. We see broken caps. The main issue, let me talk about this. Yeah, the plain bearing. So this is a kind of cool, I guess, technical dive into things. So on every rack that we've taken apart to date, and this goes with whether it's a Bronco or a Tacoma, a Tundra, the way a typical rack and pinion in a modern automobile is set up today, and the way they're designed is you have a rack and pinion on this side, and you have an assist on this side. And so like on a Tacoma, it's a hydraulic assist. This is an electric assist. Doesn't matter. What's important is, let me move my coffee so I don't knock that thing over, is right here where you see a break on this, you have a plain bearing, okay? And let's just, technically this is a plain bearing. We'll call it a load bolt because it's easier for most people to kind of grasp the concept. This sits right here, and it looks like it meshes together properly. It actually only contacts in 2 points. If you Measure the diameter of this versus measure the arc of this plain bearing. They're actually different. But the important thing is, this is how the rack bar is pushed into the pinion, and this is how you get mesh between the rack and pinion. This is the main drive force for everything. And that is put in place with a spring that I can compress, with my hands. So, you know, it's a fairly stiff spring, but it's a spring nonetheless that is meant to give adjustment. And the main issue with this is, as you load the bar, the spring is able to compress, and now the rack can come out of mesh. And this is why you're seeing failures. And so, you know, what we wanted to do when we're developing something is identify what the issue is, and then come up with a solution to change the design to address that issue. First things first, when we do something like this, we dive into reverse engineering. And I want to also be clear that when we reverse engineer everything, we test for materials, we do a lot of in-depth analysis. I'm always trying to limit the parts that we make. And so, you know, we did testing, and this is a heat-treated rack bar. It's pretty good. The pinion seemed, well, the pinion is great. Extremely complex. Do you have one that you can take apart?
Yeah, so it looks like one part.
So it looks like one piece. It's not.
Yeah, you can take this cap off. There's a little magnet guy here.
So you've got a magnetic encoder in there. You have a torsion.
Torsion bar here
inside of it.
This guy engages wheels on this sensor.
And so we're not gonna try to, if we can avoid having to remake everything, we're going to. So I want to kind of, so Eric led the design of this process, and so I'm gonna have him dive into, like, let's talk about reverse engineering. How do we do this?
Yeah, so we kind of went through and decided which parts we wanted to reuse and which parts we were going to remake. I mean, we had our design concept that we want to support the rack bar better on both sides. We want to have a different pinion support. We want to use better materials. So, you know, once we determine the rack and pinion we want to reuse, you know, because they do seem to be quality parts, the pinion's so complex. It engages with the vehicle systems. Right. You know, we don't want to change that.
You physically have circuit boards on the pinion that then can connect to and talk with the motor.
Yeah. So, you know, it's best to leave all that alone and focus on the mechanical issues that we can actually make a big difference.
Mechanical failures that we're seeing.
Yeah,
right?
exactly.
It's not like we're seeing pinion snap off.
Yeah.
Well, that would be a mechanical failure also, but we're not seeing failures on these parts.
Yeah, yeah. So, I mean, yeah, the first thing is to reverse engineer this rack so that we have a starting point. Basically trying to create a computer model where we can position all of the parts we want to reuse in space as the OE intended. So,
so how do we do that?
Yeah, so we used a CMM machine. We have one in-house for aerospace contracts.
CMM is short for, it's an acronym for Coordinate Measuring Machine.
Yeah, and that was very key to this project because, you know, your outputs are only going to be as good as your inputs. This is a gearbox, you know, at its core function, so getting the gears to mesh properly is, you know, item number one.
And why not just use a scanner? You see everybody on Instagram with the fancy scanners.
Yeah, exactly. Scanners are great for things like body panels, you know, getting footprint of things. You know, if you're doing a suspension system, you know, where you're plus or minus an 1/8 inch, 1/4 inch, whatever, it's great.
Okay.
When we're looking at fits that are going to be plus or minus a 1/2 thou or something like that, you know, we need everything dialed in, and, you know, plus or minus 1/8 inch isn't going to be good enough to position two gears in space relative to each other.
That's what the factory does.
Yeah, pretty much. Yeah. So we, you know, first thing is we're obviously going to make a new housing for this. That's at the core of our mission for this. So we need to reverse engineer this housing. And so basically what we're doing is just scanning, or not scanning, we're CMM probing all of the critical surfaces, so things like bearing bores. Typically for a gearbox, you can look at your bearing bores, probe those, and then figure out where the gears are in space. This load bolt setup actually kind of made that a little more difficult because, as soon as you take the rack bar out of the rack,
then
that spring changes. Yeah, so at the first run, you know, we're probing off of that arc there, and it's like 200 thou off of where we expect it to be.
Okay, so then how do we do it?
Yeah, so we had two different ways that we were figuring out where these are in space. One is we have a fully assembled rack from the factory, and we can go off of the diameters of the rack bar and then critical surfaces on the pinion.
And the other way? And
the other way is just clamping them together. And, you know, for all of these measurements, we're taking a large sample of parts too, because, you know, there's going to be variation.
Clamp these together.
Yeah, exactly.
Set this on a CMM, and then with a CMM, so here's the cool thing about this, right? When we're saying and taking a probe here and beeping this off, so we'll sweep this entire part here, this entire circle here, and then we'll take a bunch of measurements out and around on this. You're actually getting, in taking these three pieces in space and measuring them, you're probably getting about 30, 40,000 points. So like when it goes around a circle, it's typically taking about 8,000 measurements as it goes around, even something this small. So it's extremely precise on both diameter and positional tolerance in space.
Yeah, exactly. So when you're designing things, it's pretty rare that you have 100% control of everything that, you know, you're designing. Usually you have other people's components in there, you know, things you're reusing, stuff you're designing around. So again, just getting everything in space is the most important part. And, you know, the best way is if you get models from the people who actually make the parts.
And that's not going to happen.
It's not going to happen in this case. And then even if we did have those, we don't know their tolerances. So using the CMM and taking a large sample of measurements across several racks to create a composite, then we can kind of, you know, we see where these parts are actually coming out in their manufacturing process. Like, here's the variation of this diameter, that diameter.
Well, and I think there's something to be said for diving into it and measuring everything yourself, because like, you can get in trouble by relying on someone else's numbers. As an AS 9100 aerospace machine shop, our equipment is calibrated and certified every year. So when we go and measure things, like, we have a pretty high level of confidence that the numbers that we're getting are accurate, they're correct, and we just come up with our own process to do it. And as long as that process is validated and can repeat, then you know it's probably pretty good. Okay, so we covered kind of how we reverse engineer, and let's dive a little deeper into differences between the Haas 2.0 and the 3.0. And this is an interesting topic because while you won't find us, or I'm never going to go on forums. I've looked at some of this stuff, and I've had people email me, hey, take a look at this link, and I look at it. There's a lot of misinformation out there about what are the differences. There are no differences. Maybe there are some. Let's kind of settle this once and for all. What are the differences between the 2.0 and the 3.0?
So the two things that everyone kind of knows and talks about, first thing is motor torque. 3.0 is going to have 30% motor torque. So we have the two motors here. So you can see 3.0 larger than 2.0. So that's an external difference you can see right off the bat.
Physical bigger motor.
Physical bigger motor.
And the torque difference between those?
Supposed to be 30%. So we've never actually measured that, but we can tell with a larger tire it turns easier. So
you won't notice any difference on the road in feel between a 2.0 and a 3.0. So I get that question a bunch. You won't notice it on the road. They both drive and feel great. There's no issues. You will see a noticeable difference off-road, but we'll get into that later.
Then
housings.
Housing is the second difference. So, You know, it is a beefier housing, the 3.0 versus the 2.0.
Yep.
And it should be. There's more torque going through it. At the root of that, you know, strength is really these additional ribs here. So you can see this is the 2.0 here. This is the 3.0 here. We cut a couple of them apart. It's the same nominal wall thickness of the casting all the way through. So
you just have more ribs. And then
yeah.
What do the ribs do?
So they're gonna give you additional, basically resistance to bending in this direction. That's the main benefit of these ribs.
Okay.
You know, you'll get marginal increase in torsion and, you know, obviously more cross section, so tension and compression as well. But yeah, it's mostly just bending in this direction, which is about 45 degrees from the chassis mounting. So
okay, so what is that? What are the implications of, like, why put it at 45 degrees?
I mean, just speculation, but it looks like they're just positioned at that orientation because that was the pull of the casting, which turns out to be pretty good because then you kind of get, you know, if you're at 45 degrees, whether the frame's bending this way or that way.
So what he means by pull of casting is when they make these parts, it doesn't just magically pop out.
Yeah.
You have typically, we'll explain how casting is done.
Yeah, so you need a draft angle. Basically, you're creating a mold that you're then going to put molten material into.
Okay.
And so say these are your two halves here. You need an angle here and here and there basically so that
they can separate.
Yeah, so as you pull it apart,
yeah,
it's not dragging material out. So.
Okay, so a lot of that was probably done for manufacturing purposes.
Correct,
Not necessarily for optimal strength purposes, but it does help a little bit.
Yeah.
But again, if you're going to put 30% more torque through something, you better make the housing a little beefier.
Yeah.
And let's clarify this. Do we see failures on both 3.0 and 2.0?
Yes.
Okay.
Yeah.
And a lot of that, again, we talked about in an earlier video about materials. And we'll have a link on that. We'll go through that. So, other differences.
Yeah, so
internal differences.
Yeah.
This is an interesting one, right?
It is interesting, yeah.
So I made a comment a while ago. Internal differences are pretty much there's almost no internal difference between the two. This is correct and incorrect, right?
Yeah.
So let's explain this. I'll give you one, I'll have one, and we'll talk about it.
All right.
So you've got the 2.0
This is the 2.0. That's the 3.0. Also, this 2.0, so you see that black plastic piece comes on this one too. And we just don't have it. So that's not you might see the visual difference. It's not actually.
Yeah, so this black plastic piece is actually part of the linear bearing. So you have two different bearings in this scenario. You have an angular contact bearing and a linear bearing.
Yeah.
Linear bearings are, it's just that. It only goes in and out. Angular contacts are good because they can handle both axial and radial thrust loads.
Yeah.
Kind of a cool setup.
Yeah.
But this collar holds, there's a ton of little balls that ride in this track here that circle around the bearing.
Yeah, they recirculate through this tube.
Yeah, so it's just let's just pretend that this piece is actually on that piece.
Yeah.
All right.
Yeah.
Go.
So, yeah, I mean, we measured a sample of both. Diameters are the same.
Yeah.
Gears are the same.
Well, talk about part numbers.
Part numbers, if you look at the part number for this bearing versus that bearing, they're effectively the same bearing.
Ah, okay.
So,
let's briefly touch on this.
Yeah, what does that mean?
So, the cool thing about bearings is that one bearing number will cross-reference to every bearing manufacturer out there.
Yeah.
So let's see if this has a number on it.
This one, BN-QJ4580Z.
Okay. And here's the cool thing about bearings is that you can actually read the number, and so BN is not really, well, I guess that would be consistent.
Yeah.
So BN-QJ. So
Yep.
QJ references, and I don't know why they did this, QJ references an angular contact bearing.
Yeah.
And then you have what is it? 4580Z
Yep.
on mine.
Yeah.
So they're the same bearing number.
Yeah.
Now the only difference between these is the diameters on the outside housing.
Yeah.
Okay.
And it's
so it's the same bearing,
Yeah.
but the 3.0 will not fit in the 2.0.
no.
So let's
And
discuss.
vice versa. Yeah.
Right.
So
on the 2.0, you have these steps here.
yeah.
What are those for?
So in the 2.0, this little step here is going to have, well, so this is like a wavy O-ring essentially.
So it's a rubber wave washer.
Yeah.
Okay.
So you're gonna have one on this side and one on this side, right? So inside of the housing, you'll have a shoulder here that'll press against one wavy washer, basically. Sandwich this guy another one, and then you'll have this spacer on top with the snap ring. And then all of that is kind of preloaded when you put the snap ring in. So what that means is that this bearing is held axially by rubber. So it has a little bit of give to it.
Do we know why they did this versus this bearing?
Yeah.
That's hard. It's essentially hard mounted.
Yeah.
And the snap ring that goes in on this, you won't be able to see it in the video, but the snap ring actually has a crown to it.
Yeah.
And it can only go in one way. And so when that snap ring loads in, it kind of almost acts like a Belleville washer, I guess.
Yeah.
To where it'll preload slightly and take up the slack, but why does one have rubber around it and why is the other one hard mounted?
Yeah. I mean, driving it, I can't really
feel
tell.
the difference.
I mean, we've tested where we can tell if there's slack in the bearing.
Right.
You know, but with these two washers, we can't, feel that.
It's just one of those differences. I'm sure somebody... So let's also clarify this. Ford does not actually make this rack. Yeah. It's a third-party company. I'm sure that somebody, or I would hope that somebody there has that answer. We don't.
Yeah.
So we just kind of move on.
Yeah, we hard mount all of our setups, whether you get a 2.0 or a 3.0.
Right.
So.
Yep.
Yeah.
Okay.
So
we dove into. Sorry, we have an outline here, so we make sure we cover the good points. We dove into differences between 2.0 and 3.0, how we reverse engineer. I want to take 1 second here. So what we're doing on a lot of this stuff and what we will be doing moving forward is we found that you guys have an appetite for technical videos. If you've made it this far in the video, do both of us a favor. Subscribe to this channel, click on notifications. We're going to do a lot more of this stuff, but take the time to give us feedback. And more importantly too, if you want to learn something or if you want to know why we do something or if there's just technical aspects that you want us to dive into on any of the products that we make, leave that in the comments and we'll try and get to a lot of that stuff.
Yeah.
So let's talk about our design.
Yeah. What did we end up with?
So if we're going to design a product, we've got to feel that there's a need for it and that there's big improvements to be made. We talked about the plain bearing and the spring, and I see this as what leads to every failure that you're going to have on this rack. Because as this compresses, it can come out of mesh and one of two things can happen. So the linear bearing that's right here sits physically right at this point in the housing. So when you have deflection on this side, you're actually able to wrench this, which can lead to cracks and break this side. So I think that people often will mistakenly attribute, oh, I took a hit on the passenger side and the passenger side broke. You can actually take a hit on the driver's side and break the passenger side. You can take a hit on the driver's side and blow this cap out, because when the spring compresses at a certain point in time, you're going to go metal on metal, And this cast aluminum is a very inelastic part, which means it's just going to break. It doesn't actually bend. So material properties on cast aluminum I talk about in that same video that we linked, and the differences. So right off the bat, we knew we wanted to redesign the entire housing. And we came to the conclusion that we were going to make a major change on the pinion side of this housing. Yeah. And so here's the difference. What we do on this is we
didn't even talk about these guys.
Well,
so I guess we can
touch.
Yeah.
We can touch base on that in a second.
So.
All right, so we have an oil-impregnated bronze bushing that goes into our main housing. Do we have a main housing?
Our housing?
Yeah.
Like without the stuff in it?
Oh, I don't know. Either one.
Okay.
Well,
we got a big
we have that.
Yeah.
Okay, so this piece, I won't make you hold it for too long. Oh, you're gonna.
Yeah, I'll just put it here.
Rest it. Don't knock my coffee over. Son of a. All right. So we basically have a housing here where we have an oil impregnated bushing that has, if you see, it has a cutout for the pinion. Let me get this right. To slide into. Okay. So this cutout. Now, what ends up happening is you'll have a thrust load between this rack bar and pinion. One that pushes the pinion up and down, and one that actually wants to deflect the rack bar back and push it out the housing. That's what's actually failing on the pinion side. So when we do an oil impregnated bronze bushing that fully encompasses the rack bar, and we have no adjustment, let me be super clear on this. We have absolutely no adjustment in our rack. It is what it is. And the way that we're able to do that is not only are we able to precisionally, is that even a word?
Precision.
Not only are we able to measure with precision of where these pieces sit in space, we're able to determine what kind of backlash we want to put in there, and then we machine it one shot on a 5-axis on a very precision machine, and we're able to hit the numbers that we want.
Yeah.
So total redesign on the driver side of the entire unit based around an oil impregnated bronze bushing.
Yeah.
The aluminum housing, it's pretty straightforward. We just add a bunch of material.
Yeah.
Our entire housing is 6061 aluminum. You can see a cross section.
Yeah.
So here's the main, like, a lot of difference in this is the reason that Ford and other OEs are moving to like a cast aluminum on these parts is fuel economy. They've got to cut weight on the vehicles. They're very conscious of this. We don't care about your fuel economy.
Yeah.
So we're able to add some material and add some weight. And the other thing is, I mean, let's be honest, the way that we approach this part, we're not ever going to make 1 million of these. We're never going to make 100,000 at a time. They're making mass production on these. Our goal is to improve and make a better quality product.
Yeah.
So I guess let's talk about the bushings a little bit. So we use this same material. It's called sintered bronze. The way this is manufactured is it's actually a cast material. So it's cast under high pressure, and there's oil physically impregnated into the bronze. So when they manufacture this, they basically shove bronze powder and oil together and press the hell out of it. And so what you end up with is a material that as something either rotates or slides on it, it pulls the oil to the surface and it self-lubricates. So this is a really common material in low RPM bearing applications.
Yeah.
You see it in heavy equipment. You see it in anything that isn't going to spin fast. If you did metal on metal, what's going to happen?
Something's going to wear.
Something's going to, well, and something's going to gall.
Yeah.
Metal on metal is never a great idea unless there's some kind of lubrication between them.
Yeah.
Metal on plastic is not a great idea because the plastic's just going to wear out.
Yeah.
This is specifically designed, yes, this is a wear component.
Yeah, it is. This
Sure.
will wear too. Yes,
Everything's going to wear. So if you have metal on metal, only one of those metals is typically going to wear initially. Yeah. Whichever one is harder is going to last. Whichever one is softer is going to wear. The problem with metal on metal or metal on aluminum is you get a concept called galling.
Yeah.
And that's where one material starts scratching the other, and then suddenly everything locks up and stuff goes south really quick.
Yes.
Okay.
Yeah.
So what are
over,
we hitting next?
We went over the housing, we went over the bushing, then we have the cap side as well.
Yeah, so on the cap side,
so
I guess
we have
we
one.
Want to drag that whole heavy thing up. Oh, we have a cap.
We have
so
this guy.
oil impregnated bronze bushing on this side as well. This
versus
just adds.
Oh
yeah. Versus this is what I think this is.
Yeah, that's the 2.0. This is the 3.0.
So this is kind of a hot dog in a hallway. We tightened up tolerances a lot because we're able to hold a tight tolerance across the entire housing.
Yeah.
But essentially, what the cap and bushing does is it gives another point of contact. Should be noted that we calculated the difference in surface area.
Oh,
and we're 583% more surface area on the pinion side than what you get from the factory.
Yeah.
So the cap and on the motor side, it's just another added support.
Yeah.
Tighter tolerance on that.
Yeah. So, that's what's going to come with all of our stage 2 and 3 housings. What's the difference between those?
Yeah. So, this is kind of the point of doing these videos, I think, also, is to dive kind of deeper into the question of, okay, we have a stage 2 and a stage 3 rack.
Yeah.
What are the differences? I'll start with stage 3. So stage 3 is a rack that you're going to take out of the box, bolt into your Bronco, and you're done.
Easy.
So this is a Haas 3.0 that comes fully assembled from us. It's the easiest. It's also the most expensive because we're buying Haas 3.0s, gutting them, saving some of the parts, motor, circuit board, rack, pinion, throwing that into our housing and shipping that to you. So that's the stage 3. So stage 2 becomes a little more complicated because you can have a stage 2 for a 3.0, for a Haas 3.0, or a stage 2 for a Haas 2.0. I'll start with the stage 2 for a Haas 3.0. If you own a 23 and newer Wild Track or any Bronco Raptor, and then to make matters more complicated, which we'll touch base on later, all 24 model years, we've been told, Badlands and up are going to come with the Haas 3.0. So the takeaway on this is if you have a Haas 3.0 and you want to bulletproof that steering, you would then buy our stage 2 housing. And then you have to gut your factory rack and then put those guts into our housing. So stage 2 is a gut what you have, put it in our housing. Stage 3 is a brand new everything.
So, and if you don't know what you have, give us a call. We'll help you figure it out.
So, well,
I mean,
hold up those
the big thing is ribs on the housing.
It's pretty easy to tell what you have. You'll probably have to pull the skid plate.
Yeah.
But if you look at the housings and yours has a bunch of ribs on it, and if yours is a 2023 Wild Track, or, and I think there was even like 2022 and a half, depending on the month.
Yeah, because we had a 2.0 in the Wild Track.
Yeah,
that was
well, that was a 21 Wild Track.
Okay.
Yeah. Oh, so this is a good opportunity for us to talk about website stuff.
Yeah.
So one of the main reasons we're doing videos like this is to provide you guys with information. We're big proponents of this.
Yeah.
So if you go to our website and you click on the upper right corner, you'll see a tab called Instructions. You can go and look at full exploded views of all of this stuff. Yeah. You can look at, essentially a build sheet of individual components.
Yeah.
We have posted there a very detailed breakdown of what does it take to rip your factory rack apart, gut it, and put it into our housing.
Yeah.
We have a very detailed video of what does it take to take the factory rack out and put a 3.0 in.
Yeah.
And these videos are shot with the intention of rolling the camera the whole time. So if we struggle, you're going to see us struggle. It's not like you get some of those videos where, and then the rack just goes in, and you're like, how the does this rack actually go? If we're going to fight it, we're going to show it, because I'll be honest with you, when you put this rack in, if you choose to take the entire differential out, that's on you. If we don't recommend that and we don't do that, you're going to scratch this rack up when you put it in because it's tight. You're going to potentially fight it in one spot. Getting the pinion around the motor, you have to kind of roll things around.
Yeah.
You're not going to damage anything. You're not going to hurt our rack when you scratch it. It's going to happen. It doesn't matter. It's hidden. But we want to give you guys resources to educate yourself before you purchase.
Yes.
So we have full instructions. If you want to know what's involved in an install of Bronco portals on your Bronco before you consider buying them, we're going to give you those resources to do your own research and see what's involved.
Yeah. Yeah. You can determine if you feel comfortable doing that, or if you want to go to one of our dealers, or you know, for the.
What I'll say on this is, if you work on your own stuff and you're mechanically inclined, doing the gut swap is not that bad.
Yeah.
And like I said, when we first filmed the video, we actually had a lot of discussions internally, because we first shot it with the intention of training our dealers on how to do this.
Yeah.
And then we had a lengthy discussion, like, look, why not let the average guy, if you're comfortable, or if you want to take a stab at it, here's the tools to be successful.
Yeah.
Now, it's worth noting, and we talk about this in our video, if you don't follow the steps the specific way that we lay them out, you will have a steering fault. And to this day, we've yet to be able to correct a steering fault through any type of programming.
Yeah.
You have the potential to brick your entire steering and ruin the setup.
Yeah.
If that happens, that sucks.
Yeah.
We can't help you. But we do give you the tools to avoid that from happening. And you can watch our video on that.
Yeah, when you see a lot of exclamation marks, look, that's the spot.
Yeah. You know? We're super clear on that.
Yeah.
Okay. So yeah.
Yeah, and then, you know, if you're going through our materials and you still have questions, we would love to know that. We'd love to incorporate, you know, those type of things, feed that back into our instructions.
Yeah, we're always a big fan of criticism.
Yeah.
What I always say internally, right, when we have meetings is, it's perfectly fine to tell me that I'm stupid as long as you give me a reason for that.
Yeah.
If you just call me stupid, Well, that doesn't help me. So
Yeah.
feedback on things of what you like and what you don't like, we're always open for feedback. We love that stuff.
Definitely, definitely.
Where are we going? What do we miss?
All right, so we went through the stage 2 versus stage 3. I mean,
Yeah.
kind of talked about the stage 2 3.0. I mean, it's the same thing for the 2.0.
Yeah. Oh,
just a,
one comment I have on all of this stuff on stage 2, stage 3. So the stage 3 is a performance upgrade from Ford. So you're getting 30% more torque. That's great. On all of this stuff, our product is not a performance upgrade.
Yeah.
You're not suddenly, if you have a 2.0 rack and you're going to put our stage 2 kit in and keep everything the same, what you're buying is insurance. You're not buying performance. You're buying the insurance to know that when you smash into something that you shouldn't have, your main rack is not going to be the failure point.
yeah.
That's really it.
Yeah, I mean, I think we have gotten feedback. Some people like the feeling of this steering better. I'd probably equate that more to like if you change your ball joints out, it's going to feel slightly different.
But you're also thinking about it.
Yeah, you're thinking
and
of
you're
it. It could
paying
just
attention
be,
to it.
you know.
I
don't notice a difference.
Yeah, I'm not going to say that I notice a difference there.
Yeah.
Okay.
So stage 2, stage 3. We also have a stage 1 kit.
Oh, yeah.
So
is that floating around?
Yeah.
So stage 1, it comes in a box. It's commonly known as
the cap and bushing.
Cap and bushing. Where's the bushing? Did we not grab one?
It should have been in there. Oh, here we go.
Ah,
right there.
Okay. So cap and bushing kit. Chuck that on the ground. Where do we want to start? I guess we'll start in the full kit. So this is our stage 1 kit. On the passenger side, you have a Gucci CNC machine chunk of aluminum with an oil-impregnated bronze bushing that gives this side a bit more support. It's actually a lot more support. So this is, for all intents and purposes, the exact same part that we run on the passenger side of all of our stage 2 and stage 3 kits, with one exception. The diameter of this on our stage 1 matches the diameter of your factory 2.0 rack. This is worth noting. I should have talked about this in stage 2, stage 3.
Yeah.
All of our stage 2 and stage 3 housings require a larger boot diameter because it's the same boot diameter that the Haas 3.0 comes with.
Yeah.
So we should talk real briefly. I should jump back into stage 2, stage 3. If you're looking at stage 3, let's paint a complete picture for you. You have to buy tie rods with stage 2.
Yeah.
Because if you're going to run the factory Haas 2.0 tie rods, don't buy our steering rack.
Yeah. Because
you cannot run your factory tie rods with our steering rack because that's absolutely the weak point in the system.
Yeah.
You can stretch the boots from like an Icon. You'll struggle with that a little bit. So do we.
Yeah.
It's doable. Heat them up either with water or like a hair dryer or a heat shrink gun. You can heat those boots up and stretch them over. It's a larger, this piece here on both sides is a larger diameter that matches the Haas 3.0.
Yeah.
Or you can run the RPG stuff.
Yeah.
Their boots are the nicest boot out there, period. But if you're buying a stage 2, you're also planning on buying tie rods unless you already have the Ford Performance ones. So really briefly, I'll touch on tie rods. Factories are 14 millimeter. On the 2.0, the Ford Performance are a 16 millimeter, Icon's an 18 millimeter, and RPG or like Fouts Motorsports.
Yeah.
Or when Funhaver releases their stuff, those are going to be a Heim joint steering setup, and I'll just say for all intents and purposes, that's kind of bulletproof.
Yeah.
We will do a deep dive video or a technical video into tie rod steering setups and a ball joint style setup versus a Heim joint steering setup in a later video. There's pros and cons to both.
Yeah. I
have my personal preference, but there's applications that you would want, you know, either one. So stage one, we'll jump back into this. Cap and bushing. We sell it as a kit because if you're going to do one, you kind of want the other. I previously made statements that I feel that this is not a solution and that this is a Band-Aid.
Yeah.
Let me clarify that. I think that this is not the end-all be-all solution, and when we developed our steering setup, I inherently want to go to the best product that I can possibly make.
Yeah.
Which is stage 3. Or stage 2, really. It's the same thing. It's just different motor torque. We had so many people that reached out to us that said, hey, can you build a cap and bushing? We said, initially I said no.
Yeah.
And then more and more of you reached out and said, we want a cap and bushing.
Yeah.
And I said, okay, so
we already make this.
We already make this, and literally the difference is this diameter.
Yeah.
So we already make this. Okay, then we need to discuss a bushing. So there's a couple companies that make bushings.
Yep.
Ours is very different than those.
Yeah.
We'll talk about materials. I'm a huge fan of material science. I don't claim to be a material scientist, but like anything, if you want to learn about something, go down the rabbit hole, read about it. The information's out there. So I guess let me talk really briefly about how stage 1 works and why I say it's a Band-Aid fix.
Yeah.
So I'll still stand behind that statement that it's a Band-Aid fix because you have a lobe on this. This piece presses into the cast housing.
Yeah.
Now, every cast housing that we measured had a different location on the rack bar in relation to this lobe.
Yeah.
So essentially, your rack bar is going to be floating somewhere around here. Okay.
Yeah. And
so it's an imperfect setup.
Well, it's the wrong side.
Yeah, well, we cut that side off.
Yeah, I mean, they make that lobe by basically facing off part of this cast surface in here, and casting tolerances are
it's not a precision part.
Yeah.
So we kind of have to go off of, you're never going to make this, if you made this out of steel and made it tight tolerance to fit this bar, or even make it out of oil impregnated bronze and make it tight tolerance.
Yeah.
It's either not going to fit, or it's going to be loose, or you're going to end up bending the bar in relation to the housing, and the housing's going to fail.
Yeah.
So too tight of a press on this, you're going to induce stress into the housing, and something's going to break. So when you're pressing this onto this side, I talked about how we capture with our oil impregnated bronze bushing, we support behind the pinion where the rack bar wants to deflect. This is going to sit out here. So does this help mitigate bending moments and bending moments from out here? Yes. Where should you be supporting? Right behind the pinion. So if the pinion's sitting here, this bushing is out here. You want to support on both sides of that pinion and behind it. That's where the load is. Supporting out here is better than nothing.
Yeah.
And so
it's limiting deflection.
It is going to limit deflection. It's also going to induce that into the housing.
Yeah.
It is what it is. It's better than doing nothing. So the difference between, I guess, the things that we changed when we developed this is most people, how do I say this? There's a ton of different types of plastics.
Yeah.
Super common in off-road applications are Well, there's a type of plastic called Delrin. Delrin is the name brand version of it. It's acetyl plastic. It has a very high tensile and yield strength, but a very low impact rating. So it's a super hard plastic. It works good for, well, people often use it for sway bars.
Yeah.
Like to hold the sway bar on the chassis. It's a hard, durable plastic, but it doesn't have a great impact load rating. It has a very high, it's a strong plastic, but it wasn't what I thought was the right choice for this application, because what I want is a plastic that can take a hit and deflect. But the problem with that is that also means that it's going to be probably relatively soft on the durometer scale. Durometer scale is how hard that plastic is. So we picked a UHMW plastic. So it's an ultra high molecular weight. It's commonly used on, like, I used it on skid plates back in the day on buggies that I built.
Yeah, it's definitely a trend right now in skid plates for Jeeps.
You can physically take your fingernail and dent UHMW. It's fairly soft. Here's the beauty of UHMW. I remember, you know, back in the day, I could smash UHMW into rocks. It's never going to break. It just deflects and it just kind of smears out of the way. It's 18 times more impact resistant than acetyl.
Yeah.
But being that it's soft, if we had this hardened steel rack bar on UHMW, it's going to wear pretty quick.
Yeah.
So we do a two-piece design where we take a UHMW housing so it can take impact loads. We machine out and slide in an oil-impregnated bronze bushing, which has really good wear-resistant characteristics, and we put it together. So I still think I'm going to stand behind the statement that it's a Band-Aid fix, but let me be clear on this. It's a Band-Aid fix for some, it's perfectly fine for others.
Yeah. So then who would you recommend this kit for?
Up to 35-inch tires, mild off-roading, it's absolutely better than doing nothing.
Yeah.
The only way I would say that this is worse than doing nothing is if you go to put the stage one in and you have to physically, like, and unfortunately, you're never going to be able to feel this.
Yeah.
If you had to bend the bar because it was so far out that you had to, you know, bend the bar to smash it into the housing, that's not a good idea.
Yeah.
But part of the reason we use a softer plastic is when you go to tap it into the housing, it's more malleable.
It finds its home.
It'll find its home.
Yeah.
So, yeah, I mean, if you're going to be on stock tires, you want a little bit of insurance upgrade. You hear that people are breaking these things and you want to do a little upgrade. It works.
So then for the full billet housings, going from a 2.0 motor to a 3.0 motor, or a Haas 2.0 versus Haas 3.0?
Yeah, well, I guess when we talk about what kit is right for you, I get phone calls on this, and I always kind of answer the question with a question, which is, what size tire are you planning on running? And the second question is, what terrain are you running? So 35-inch tires, dirt roads, mild off-roading, stage one, totally fine.
Yeah.
Going up to 37s, I would tell you 35s to 37s is kind of our stage 2 or stage 3 realm. And how do you determine, do you need a stage 3? If you are wheeling Sand Hollow, Moab, Utah, Slick Rock, if there is a shit ton of traction where you wheel, you want the stage 3, because you'll actually end up stalling out the motor. So like I was wheeling with Bailey Cole out in Sand Hollow a month ago, and he was in the Icon Bronco, Icon Vehicle Dynamics. He was in their Bronco running 37s, and he was physically stalling the steering to where like he just would lose all steering. And that's on a 37-inch tire.
Yeah.
But that's also on slick rock. It's essentially like more traction than pavement. And you're in low range.
Yeah.
And you have your locker on and you go to turn and the steering just can't produce enough torque.
Yeah.
If you wheel those spots, just go to the stage 3. Do yourself a favor, you'll be happy with it.
Yeah.
If you wheel more loose terrain, dirt with rock thrown in, I think the stage 2 is probably fine, is totally fine with 37s. There's no such thing as too much power in a steering system, I would argue. You might break other components, but your steering's still going to be good.
Yeah. I mean, that's a good segue into, you know, there's always that fuse. So once you've gone to the full billet rack, what do we think's the next? Yeah, because if you go hard enough, you're going to break something.
So we actually had a really cool empirical data on this.
Yeah.
I got a text message from a buddy of mine in the Pacific Northwest who was running, well, he lives in Utah, but he was in the Pacific Northwest right after Overland Expo Pacific Northwest. And I get a text from him and he goes, and it's just a photo, and his steering wheel is kicked 90 degrees. So Bronco Raptor, he's driving straight, and the steering wheel is sideways.
Yeah, love those no context picture messages.
Just text message. It was like a weekend or something. And they were on the beginning of a 5 or 7 day like excursion across the Pacific Northwest, part of elevated off-road experience. So I get that text and the steering wheel's kicked sideways, and I go, and he goes, something went wrong. I hit a tree. So he hit a tree. I get more details. I immediately pick up the phone like, you hit a tree. He's doing 25 miles an hour behind another vehicle in the dust. He kind of veers off to the side and literally clips a tree with his, I don't know if it was driver or passenger front tire, but basically tire to tree, tree doesn't move, vehicle dead stops, steering wheel rips out of his hands. Luckily his thumbs were not in the steering wheel. Keep your thumbs out. They probably would have been broken.
Yeah.
Hands go forward. It was so violent that it literally burned skin off of his forearm, tearing the wheel out of his hands. Vehicle dead stops. Something's wrong, because it no longer goes straight. So what ended up happening was he went back to camp and kind of, steering is still there, everything's fine. Now I should preface this, he's running RPG tie rods, Heim joint with a clevis. We'll do a steering video on differences between tie rod ends and Heim joints later. But that steering linkage is just not going to fail that I could see in this scenario. So what ended up happening was he blew the lower cam alignment out of the lower A-arm, essentially. And so on your lower A-arm, the way you adjust... you
can adjust camber.
You can adjust camber. You're not going to adjust caster with it. You can adjust camber with it, which is how the wheel sits in or out. So positive camber, negative camber. You adjust that with that cam alignment bushing. So he actually pulled the arm, the whole A-arm, out, drove into town the next day, realigned everything, everything was fine. So when we say it's a bulletproof solution, we hit a tree doing 25 and nothing broke. I will make this comment This is not a bulletproof steering solution. We have personally, and we know a bunch of companies that have, well, I've seen 3 or 4 racks come to us that are broken, that have been brought to us by customers who had a bushing in them, broke the rack, and then went to our stage 3. So it's definitely an upgrade, but it's not your 100% fix-it solution. I don't think anything is ever a 100% fix-it solution.
No. Just gets you to that next level.
Yeah.
So.
Which, okay, the perfect transition, our last topic.
Yeah, warranty. We get
Warranty.
a lot of questions about warranty.
So it's a perfect comment to transition into. I'll call our stage 2, stage 3 bulletproof. Here's what I mean by that. Nobody's ever been able to break it. Lauren Healy runs 42s and jumps the shit out of that Fun Runner XL. And we have video of him skyrocketing the thing and literally landing on the front end of that vehicle, stuffing it down. If you're not breaking it on 42s and you're not breaking the steering rack by hitting a tree doing 25 miles an hour, you're probably not going to break it. But anything is breakable. When it comes to warranty on our steering rack, if we make it and it's out of aluminum, it's a lifetime warranty. I'm not going to give you a lifetime warranty on the internals that we didn't make. I'll tell you that we haven't ever actually seen internals break. And I'm sure we will at some point in time. But if we make the part, we'll give a lifetime warranty on it. And I don't care if you bought it from somebody who bought it from somebody who bought it on Craigslist. If we make the part, I'll stand behind the part. You don't need to register it. There's no, you have 12 days to register your product on our website or it's not covered under, I don't give a shit. Like, it's a lifetime warranty, and I'll offer that because you're not going to take us up on it. And if you do, here's the way the warranty works. You call us up and say you broke it. You send us the broken part. We send you a new part. And I'll even send you a new part before you send it to us. We like to get broken parts because that's part of engineering is
we want to know how you broke it. We want to incorporate that back into the design.
Be honest. Don't be like, oh, well, I was just driving in the parking lot and I hit a curb. Like, I don't care what you did. I don't care if you, well, I was doing 80 and I hit a K-rail. Well, I mean, it's not going to go back on the vehicle. But
if you have a video, send it to us. We'd love to see it.
So, again, help us grow this channel. We will be producing a lot more regular technical content. We're going to spend a bunch of time in 2024. And this is, we're filming this in November, late November 2023. We really want to generate a lot more of this stuff. So help us out. Tell us in the comment section what else you want to hear about. What other technical things you want to dive into. And this doesn't actually need to necessarily pertain to our specific products. If there's something that you want us to address and we feel we could talk about it, we'll do it. Our goal is to generate a lot more technical content to answer questions that you guys would have. Because when I want to learn about something, I dive down the YouTube rabbit hole because it's super useful. So we want to be a resource for you to be able to do that. And so, I'll do smash the
smash the bell.
Yeah, smash the bell. Subscribe to us. But it does actually help because it indicates that you see value in our videos and that you want more of this stuff. So do give us feedback.
We read the comments.
I try to personally respond to comments and try to address everything. And if we don't, you can always email us, info@74weld.com. And until next time, thanks for watching.